Okay. All right. So welcome to the second Corundum developer meeting of 2022. I know we had one 2 weeks ago, but the turnout was, relatively small. So we can kick this off with, a proper meeting today, hopefully. Okay. So to start out with, I have a couple of status update slides covering some of the things that I've been working on over the past couple of weeks and what I'm going to be working on over the next couple of weeks. So let's go ahead and go through these. So this is a couple of things that I got kind of knocked off. The biggest one, I think, is the address space reorganization. That's all been checked out and committed. And I've also added the initial version of the shared interface data path. All those changes have been pushed up to the repository. Um, and then I have a whole bunch of kind of to-do items. Some of these I'm going to be working on, over the next couple of weeks. Some are a little bit longer. So the variable length descriptor support, that's something that this can unfortunately has been getting kicked down the road for quite a while. At some point relatively soon, I'm actually going to work on that. The PHY control and status registers and the GTY and PLL DRP interface connections, that is stuff that I'm going to be working on over the next couple of weeks. At UCSD, we've actually been doing some testing that involves some link layer stuff. And as part of that, we've determined that we need a little bit more visibility and control into what's going on at the link level. So I'm going to take a crack at getting a couple of those pieces operational. Then I also have a to-do item for 10G, 25G switching, and then also documentation. Now that things are starting to come together a little bit better, I figure let's start putting together documentation, as we go. So I'm gonna start getting that set up within the next week or two, hopefully. All right, so let's go over a couple of these in a little more detail. So the register space reorg, I've put the slide up a few times, so hopefully some of you guys are familiar with this. The idea is to rework the register space to use kind of PSK config space style blocks that can be enumerated by the driver or by the user space tools. They'll have, a very simple header, which has, a block type, block version, and then a next header pointer. And the great thing about this is you can, the offsets are not so important. You can move things around. They're easy to enumerate. And you can either have blocks that contain registers themselves, or you can have blocks with like an offset pointer to a block register somewhere else. So it's like, that's kind of the downside of using headers, is that if you have a nice, 2 to the n block of registers and you whack a header on it, now it's not 2 to the n anymore. So it can be difficult to cram stuff together. But if we can separate the block from the registers when necessary, then that'll allow things to pack a little bit nicer into the register space. This allows you to support fine-grained versioning. So if I need to change registers or add registers or whatever, I can just bump the block version numbers, and then the driver, won't talk to that block. So that will allow you to, keep things up to date without having, weird interactions if you're using an old version of the driver or an old version of the FPGA code. You'll get a warning or error message about it instead of having some unexpected behavior. And I've also checked to make sure that the firmware update tools will work even if the interface registers have changed. Basically, the code will bail out of setting up the interfaces if it can't find a block that it's looking for. And this makes it a lot easier to customize and add components. There's a bunch of stuff that I've been kind of putting off because I'm not really sure the best set of registers to use. Well, now if I can just version the register block, I'll just put something together relatively simple. We'll get the functionality working, and then down the road, if there's some sort of an issue, we can rework the register block and bump the version numbers, and then everything will work. So the initial version of this is done. It's been pushed to the repository. The driver, user space tools have all been updated. So all the current Corundum designs are using this new register space organization. And I know there was some discussion about this before in terms of, how do you prevent the old version of the driver pre the register space reorganization from trying to talk to the new hardware, and, vice versa. What I ended up doing is setting, when the driver loads, it checks to see if it can talk to the card properly. And if the card needs to be reset, then basically the entire memory space reads as, hex FFFF. So what I ended up doing is setting the type field for the firmware ID block to all Fs, and that ends up being the first D word in that block. So the old driver just thinks the card needs to be reset, and it never tries to talk to it. So now I don't need to bump the PCIe device IDs or whatever. So yeah, so we're good to go with this new setup, and going forward, this will make it a lot easier to integrate stuff. All right, so that's that. Then I also pushed up the current version of the shared interface data path. The idea with this is it reduces the resource consumption, and it also provides some more flexibility to the application logic in terms of moving packets between different interfaces. And hopefully this will also be able to support traffic classes for prioritization and PFC and whatnot. There's still a number of things that I need to implement. So if you have multiple ports on one interface, we need to have some sort of internal flow control so they don't, step on each other. That's still a to-do at this point. And then also I want to implement some shared memory FIFOs that are going to be more efficient from a resource consumption perspective. So that's still a to-do, but the core data path has been pushed up. And if you just have a single port per interface, then you don't necessarily need some of these other features for things to work correctly. All right, so I have a couple slides with a little bit more detail on the shared interface data path that I've presented before, so I'll skip over these. But yeah, the idea is that we're going to be providing more information to the application section and whatever additional logic might have been added, and that'll make things a little bit easier to work with. Okay, let's see. And moving on to variable length descriptor support. There's a couple of reasoning behind doing this. The first one is that it's going to provide a more efficient method for reading information from the descriptor rings over PCI Express, so to reduce the traffic over the PCI Express link, and then it'll also allow more complex offloading as well as properly implementing scatter gather DMA. So I need to do a bunch of work on this, overhauling the queue management logic and the descriptor and completion handling logic. So it's a pretty big set of changes, but that's something that that I'm working on, piece by piece. Originally, I was going to do this a little bit later, but now that I have the version register blocks, I can work on this, earlier and get it integrated, and then we can transition over to using that. All right, so now moving on to more link level stuff. Right now, the PHYs are just kind of doing their own thing, and there's no visibility from the driver as to what the PHYs are doing. So what I want to do is add some control and status registers to expose some of the status signals, LOS, block, things like that, and also permit the driver to control some link settings. So reset the PHYs, change FEC settings, disable the transmitter, change the link speed, things like that. So now that I have the register blocks, I'm going to go ahead and hammer on this and get this working, so at least we can see like the link state from the driver. So I'm going to be working on that over the next couple of weeks. And then another thing that we've determined that we need for the experiments we're doing at UCSD is the ability to poke at the transceiver DRP interfaces, because this allows you to do some pretty low level FPGA specific link level diagnostics. You can tune various parameters, the equalization, emphasis settings, swing, etc. And you can also do some low level monitoring of the link. And then there's also the eye scan feature that will allow you to measure an eye diagram from the standpoint of the FPGA. So I'm going to go ahead and get this integrated over the next couple of weeks. And one thing to keep in mind is that this interface will not be used by the driver, only by the Userspace tools, because I'm trying to avoid board specific and FPGA specific code in the driver as much as possible. But we will probably be adding some Userspace tools that can talk to this for running iScan and whatnot. So I'm going to be working on that over the next couple of weeks. Let's see, and then I also have a to-do item for 10G25G switching. This one allow you to mix and match 10 gig and 25 gig interfaces in the same design. by allowing you to do runtime switching between 10 gig and 25 gig. And I had asked Adam John to take a look at this because he sounded interested in working on some transceiver level stuff. So once I have the PHY CSR set up, then hopefully we'll be able to test this out on the FPGA. There's also a couple of related to-dos that I need to do right now. Resetting the transmitter is somewhat problematic because if we lose any PTP timestamps on the transmit direction, then that causes the transmit edge to get all screwed up. So I need to make some adjustments to that before this can be properly implemented. But yeah, that's almost the last thing. Okay, then we have documentation. I know there's quite a lack of documentation in the repository right now. What I want to do is get Sphinx set up. There's a bunch of different projects that use that, Linux kernel, CocoaDB, etc. So I'm somewhat familiar with how it works. I'm going to get Sphinx set up over the next week or two, and then start, filling in bits and pieces of documentation so that it stays in sync with the repository as we start implementing new features. So the idea is that every time we implement, a new feature, we'll also, put the corresponding documentation into Sphinx. So, all right. And then I've been putting the slide up, kind of the to-do list for this before we can start, releasing versioned releases. And let's see. So we've checked off basically 2.5, something like that, of the items on here. Application section, that's done. Register space reorganization, that's done. Shared interface data path still needs some work, but we have at least the initial version committed. We need to make some changes to the checksum offloading. That's still to do. Variable length descriptor support, that's to do. And the FPGA management software, one of these days, soon, I'm going to get that operational. And the overall goal of this is to stabilize the driver and hardware interface such that it's easier to, such that we can, peel off the driver and get it upstream to into the Linux kernel, or, run with a driver from a separate, DPDK repository or whatever, without having, a lot of board specific and FPGA specific code in the driver that has to be updated all the time. So anyway, once we get to this point, then that's going to make things a lot nicer. Anyway, that's all I got for status updates for this week. I'm not sure if anybody else has anything that they want to share, and particularly the folks from MLE. I know you guys have a lot of stuff on the back burner. I'm not sure if there's anything that you guys want to update us on that you've been working on in terms of DPDK or Zinc support or whatever, or if there's anybody else. Ulrich, did you want to say something?
Yes, the double mute, sorry.
Okay.
Sometimes it also hits me. Yes, so let me just drop a couple of items. I didn't prepare any slides. I'm really working a lot on our PCB side currently, as semiconductor shortage also hits our project now. But yes, we are also tackling some items in Corundum. You already said it. So MPSoC support is currently really on the back burner. So we are looking into our shaping implementation, which comes along quite nicely. And the driver side, I guess Joachim may spend 1 or 2 words about it afterwards. And the Intel port that you also provided initially. So we are still working on some optimizations in the code, as some of the regular structures do not really match what the Intel compiler likes to see to map the little small RAMs into the MLabs. So that's something we are currently working on.
I annotated a lot of those, which I think improved the situation, but it's entirely possible I missed some, and it's also possible that it's not converting some of the ones even though they are annotated. So, but yeah,
well, it's not about annotation. So we figured it out now, and also we had some help from Intel as well. So it's really one important item is you have to register all signals going into the MLab. So each select, enable, address, data, whatever needs to be registered dedicatedly for the memory data path. So you even may not use it on the side to increment the address as well. So that's already a violation of the style.
Okay. Yeah, I think I actually ran into a similar issue with some of the Xilinx ones as well, but I think it was less in terms of just outright inferring it and more about allowing stuff to merge into the internal flip-flops that they have.
Right. Yeah, and I guess for your initial implementation, it just didn't matter anymore because your FPGA is quite big enough and you have enough block RAMs, and that's fine. But we are running into trouble there, so we need to use those and move those RAMs.
Well, you're talking
into
about
MLabs.
the initial implementation on the Intel devices?
Yes.
Okay. Yeah, I mean, my goal is mainly just to get it to build and close timing. So and then we'd
no worries.
We'd hammer out all this stuff later. So
exactly,
right.
and that's
and
what we are currently doing.
On a smaller, slower device. So all right, I guess we gotta rework a few things to make it work. So all right, that's good.
Yeah, no, right. So we already had so we are kind of hammered on one module to figure out how to actually do this, and it comes along now in a shape where it at least passes simulation and still is translated on synthesis level into the right RAM. And especially for the Xilinx side, it doesn't mean or it doesn't have a big impact. So it's kind of another register. Of course, it's also there in the Xilinx world, but that's I guess only beneficial for the timing aspect. So it doesn't increase usage a lot. So I guess that's okay, and it can be left in the code base. Once we have the patches ready, we will just provide them as in the past, I guess. So we're currently internally reviewing them and look at 2 additional locations. There's kind of 2 or 3 basic ways that MLabs are expressed. Yeah. Right. So we are looking at those, modifying them, and once we see that it should work, we will just provide a merge request or pull request, and then I guess that should come along.
Right. I mean, it'd be nice if you could pass along just a little summary of what some of these changes are, just kind of as a heads up. And then if I'm, working on something, it'll be like, oh, I should use this style. So it actually works on the Intel devices.
Yes,
so I'm not creating more work for you guys.
Yeah, I guess my colleague just looked at your diff as you have been busy throughout the last weeks, and I guess that's not really touching those code locations, so that's fine.
Right. Yeah, I think but potentially some of the other changes that I'm going to be working on at some point in the near future might, right? Some of the variable length descriptor stuff is going to touch like the queue management logic and a couple related components. And I think there's a lot more RAMs used in those. So anyway, we'll cross that bridge when we get there.
Exactly. Yeah. I guess that's currently the things that I get out of my head right now spontaneously. I guess the 2 of us, I don't know, maybe we should have another discussion about our FOSDEM thing.
Right. Yes, that's a good idea.
So deadline for the video is like 21st, so it's not so far away. They spent more time to select the talks than they already wanted to spend. So I guess if it's okay for you, we can have another meeting later today, or I don't know, very early for me tomorrow. I don't know what's better for you. So I have to run like on the next full hour for another meeting, and that will probably last for at least half an hour, maybe an hour.
Right. Yeah, I mean, maybe tomorrow would be, well, I don't know. We can discuss that in an email or something. I mean, yeah, I could certainly do. Well, I guess the other thing I could do is, like sometime this evening, my time, which could be morning your time. Although I don't know, maybe that would conflict with actually getting work done on your end.
Well, no, for me it's fine. So tomorrow I'm up quite early, at least for my usual habits. So
Okay.
I guess I'm actually really in the office, which I'm also physically very rarely, but like at 8ish in the morning, which is actually maybe a possible time for you in the evening to do a call. I don't know.
Yeah, that could work. If that works for you, then I can make that work on my end. Yeah. All right. Sounds
okay,
good.
cool.
Yeah, why don't you send me an invite email or something, and we can figure that out.
Yes, I do so. Okay, cool. Yeah, so that's, I guess, from my side. Maybe Joachim want to spend 2 or 3 words about his driver side and queue selection. Although he's currently also a little bit distracted from another project, but yeah.
Yeah, that's right. But still, yeah, I've put together a suggestion for having a custom queue, TX queue selection mechanism in the MQNIC driver. As far as I know, the Linux kernel does not directly offer such a functionality. And that functionality, at least we need such a functionality where a third-party driver can decide or decides about where a package should be sent to which queue specifically. And the network stack in the Linux kernel has a callback for that. For each network interface, it's called the NDO select queue. And yeah, well, it's supposed to return a queue index, which then the Linux kernel uses when sending a packet down to the NIC. And we need this to be selectable by a separate entity, a separate module. And for this purpose, I've added a custom API. Of course, it's custom. It's not standard Linux in this case. That has to be clear. Yeah, Alex, I saw your replies, but unfortunately didn't have time up until now. I will look into them. And of course, our thinking is that perhaps, at some point in time, if time is left, we will go to upstream and ask the Linux network maintainers what they think of it.
Yeah, that whole queue selection thing on the transmit side, it seems like there's a lot of use cases for that potentially, but it may need to be integrated in a different way into the stack. It just right now it seems, to be honest, like a very strange way of dealing with the queue, right? Like I think how it works is the Linux kernel will ask the driver what queue to put a packet in, and then it will go stick it in the queue disk, and then eventually it will make its way back to the driver. And it's like, well, why is the driver of all things deciding which queue to use? It seems like that should be left to somewhere else in the stack, because you might want to have some sort of a policy or something, or assign particular connections to particular queues or something like that. I don't know. Seems like a strange design decision, and we could certainly add APIs to fix that. I mean, it seems like that's what we're going to have to do in the short term, but almost seems like a long-term solution in Linux is not add another API, but kind of take a step back and rethink what's going on here. Anyway.
Yeah. Can be, yes. I have to say, for me, the question is there any way via TC? And the problem I see there is TC is meant to be controlled by Userspace. And so this is basically my question here. Is there a possibility to do that via TC, but in a way which is compatible with the fact that, well, TC is controlled via Userspace, so it's kind of a dual use here. Then kind of the kernel would have this third-party module would have to somehow interface with TC and not conflict with Userspace.
Yeah, I know
that's
TC
where my
does
picture
have,
isn't clear.
right. Yeah, I know TC does have an option for making some edits to the SKB, including setting the destination queue. But yeah, I see what you mean by that being a user space versus kernel thing. So yeah, not sure what makes the most sense there. I think what happens when most people kind of get to this level is they just end up doing the whole thing in DPDK and then skipping the kernels. So, or, you know, an equivalent kind of user space setup, or they use like VFs or something like that, and then, you know, leave it up to the NIC. I don't know.
Yeah.
I guess it depends on the specifics of the application as to what's going to make the most sense. Anyway, I did take a look at the commits. It does seem like, I think, a reasonable thing to add. We might just need to make a couple of, you know, small tweaks, I think. But yeah.
I will have a look at it. And yeah, I mean, the goal here is obviously I try to make it optional so that nobody is forced to include that if there are doubts about performance. And well, in the end, is it another action the CPU has to take? So at some point it's hurting performance for sure.
Well, actually, so
Question
that's an interesting point. That was one of the comments that I made, I think, on the pull request that you made, is in terms of, you know, swapping out the entire net device ops structure just to add that one callback. I think the default for that callback is just null. So if instead of swapping out the entire structure, we just, you know, basically keep a copy of that structure inside of, you know, the top level mconnect dev or whatever struct, then we can just edit that pointer, right? So when you want to enable the feature, then you write the callback over the, you know, default null value. And then if you disable, then you just write null again. And I think that would, you know, give you that feature without, you know, adding any performance overhead, because you're just changing a pointer. You're not actually adding any additional code.
Right. But that's just another way to write it. Yeah, you're right. That's
well, right. But if you do that, then there's no performance penalty, right? Because if you don't use it, then it doesn't even modify the NDO whatever callbacks. So
yeah,
that code never gets touched. So yeah, I think that was one other concern that I had, is like making it optional like that. Now you got to jump through a couple extra hoops if you want to build it. You got to, you know, specify on the command line, you know, do this thing instead of the default. So, I mean, that's not such a big deal, but it's more like there isn't any, as far as I can tell, nice kind of persistent way. Like we always want to build this. You just hit make and then it builds it. So I don't know. Well, we can do some ruminating on that. I would be fine making it just kind of a permanent feature that's always there. If I don't think that would be all that big of a deal to do, but anyway, we can discuss that later.
Okay.
When you have some more time. So I know one thing I wanted to talk to you guys at MLE about is the DPDK support that you've been working on. I don't know if either of you know anything about the progress of that, or if we have to get excuse me, whoever it was on here who's working on that to talk about it at some point. Ulrich, do you know more about that, or?
Yes. So that was kind of a side project of the product team, let's say, and I guess we had so the guy working on this is kind of one of our newbies. So
okay.
He's not obviously it takes him more time as others to dig into this quite complex project. But however, I guess we are pretty close to actually having something that at least is capable of exchanging packets with the RTL. So I guess what is missing right now is first that should work. But on the way there, I guess we will do some closer internal code review and see whether there is some obvious stuff we want to close off first. And then I guess we can release something to public that we can jointly work on, even though it doesn't fully work, let's say. What we did is, and I guess that's now a question how we organize this. So from our understanding, there is kind of two repositories for DPDK. There is the stable one and the kind of development one. So right now we use the stable one because we think it's also not fully understood yet, but we think that our customer will run some stable version and needs an extended one or complemented one with the named QNIC driver. And I guess maybe that's not your use case, because you want to probably upstream this once register changes and variable descriptor length is in place, right?
I mean,
so
at
the question
some point,
is how
but
to
it's not a super high priority to get it upstreamed. So
okay,
that's kind of the long-term goal.
So I guess then it could be fine to start with our approach and use the stable repo and just add a driver to this one, and then I guess most people can kind of just swap this out and use it, right? I don't know what your plan is. I guess you wanted to use it in your setup as well, right?
Right. Yeah. So it seems like for the setup that we're working on, that we need to get the open vSwitch operational, and that uses DPDK as the backend. So, yeah, that means we kind of have to do something with DPDK. So, as for kind of how much throughput we're going to need and whatnot, obviously the more the better. So if we have to do some optimizing and whatnot, then I guess that's what we got to do. But yeah. And I think there's been a number of people that have asked about DPDK support as well. So, it would be nice to have something we can point people at, saying, hey, you can modify this or work on that.
Exactly.
Although I guess there's definitely a difference between people that just want to, grab it and use it versus actually help make it work. So,
of course, yeah. But I guess having something to start from is always
right.
worth.
Definitely.
Yeah. So I guess that makes sense, and I guess haven't been there like throughout the last half year of these meetings. Every now and then somebody popping up saying, okay, I'm doing a driver right now. And did you see any outcome of this that has been reported to the project?
Not a whole I have not seen any source code come out of a lot of this stuff. I know who was it that I was talking to recently. I guess Jashin was doing some stuff with the Userspace code. I think she didn't write like a DPDK driver or something, but did something simpler, kind of.
Yeah, I guess it was some custom Userspace.
And she was doing some benchmarking on that. She said she had some results and some graphs that might be interesting to put up at some point, but she hasn't been at the last couple of meetings, so I might need to reach out and see what the status is on that. But yeah, she did get it to the point where she could send and receive packets, but I don't think she's posted any code publicly. I don't know. A lot of research grade code, you're like, I don't want to publish this because it's terrible code. And who's going to look at it?
Exactly. I get this point, and it makes total sense. I guess that it's not just in research areas. I guess we also don't want to see a lot of code that is running productively on machines. I don't know, doing whatever machinery, controlling machinery, right? So that's just how it is. Yeah. Okay. Yeah. So I guess so we have definitely a target, and that's ranging in soon where we want to complete this. So this is within the range of weeks. Right. So I guess it depends on your timeline. If you want to have something earlier to play with, we can make this work. If it's okay for you to wait for a couple of weeks, then we will just provide something that is more ready, let's say.
Right. Yeah. So there's unfortunately been a little bit of some changes in plans and whatnot on our end. So yeah, I think waiting a couple of weeks will be fine. We're doing a lot of link level stuff right now. So yeah, that doesn't require DPDK.
Yes. Okay. Yeah. Good. Then we can just, yeah, let's say
Right.
leave it as
I
it
was just
is.
more in
and
terms of,
we'll-
let's stay in the loop on progress and whatnot. And also said it before, I'll say it again. If you guys are running into any issues or have any questions, please let me know. I know. I think who was the guy working on that? He
Bjorn.
asked, he posted something. Bjorn, yeah, okay, yeah. He posted something on the Slack channel a while ago saying he was running into kernel panics or something like that.
Yes.
And then I managed to figure out what he needed to do, but aside from never really working with DPDK before. And then after that, didn't hear anything. So it's like, okay, he had a question about DBTK, which I was able to solve, but he hasn't asked anything about the actual, hardware. So yeah,
Exactly.
anyway.
Yeah. No, so what we have right now is so setting up everything passes.
Right.
So DPDK at least is fine with the infrastructure provided in this PMD. But then at some point the receive loop crashes. So I guess there is something in the interaction with the DMA engine which is not set up correctly right now.
Crashes, how so? It just stops, or you get kernel panic, or what?
Well, a ZEC fault in the DPDK code somewhere.
Hmm.
But I guess that's kind of the same thing, which would be a crash within the Linux kernel, right?
Right. Yeah. Okay.
Yeah, the problem is I've had some back and forth with Bjorn on that. I mean, I don't do anything with DBTK and I don't know much about it, but obviously the point is that the documentation kind of is not there for writing a driver.
Oh, on the DPDK side or on the Corundum side?
On the DBTK side.
Ah, okay.
Documentation about the PMD interface itself. The documentation on writing an application using DPDK seems to be there, but for writing a driver, it's I didn't see any. But well, and the point is, you have to fill out a bunch of structure members, and my impression is you basically don't know which ones are optional and what you have to fill in. That's my take. And so that proved to be the source of a lot of these segmentation faults.
So something wasn't being set correctly that should have been set. Okay.
Yeah, right. Yeah.
Yeah, when I wrote the drivers for Corundum, my main references were not documentation. It was just driver source code for other drivers. So, and then, yeah, the hard part is figuring out what parts are relevant and what parts are can be removed. So,
yeah.
Anyway, so it sounds like the problems you're running into are maybe more likely on the DPDK interface side and less so on the Corundum side. So
that's my suspicion. Yes.
All right. Well, hopefully you guys can get to the bottom of that. All right. Well, let's see. Is there anybody else that wants to talk about status updates? I know, Adam, John, you were doing some work on the 10G25G stuff. Do you want to mention anything about that or keep that under wraps until it's actually working?
Yeah, I will talk about it, but I won't talk about it using a presentation or something next time at next meeting.
Sure.
And what can I say today is that now 10 to 25G switching is working on example design, and we are using 2 different QPLLs, as you know, and I am planning to test it this week, and after that I want to do the power down of QPLLs and channels. Well, let's see what happens this week. Last 2 weeks I couldn't work. I was busy, but this week I will continue.
Okay, so you said it's working in simulation.
Yes, it's working in simulation, definitely.
Okay, so you haven't put
But
it on the
I
hardware
want
yet,
to test
which
it
is
in real life, yes.
right.
In
Yeah,
hardware.
simulation is
want
good.
to-
That's definitely a good step, but you know, especially for things like transceivers, you got to test it in hardware to make sure you haven't
Yes,
missed
yes,
anything
because
so.
mostly it doesn't work. It's not like the other parts of logic, as you know. Sometimes something very small detail can spoil everything, as you know. So I want to test like by enabling 2 transceivers from different places and connect with cable from outside, and there will be a real loopback and I will see what happens.
All right. Well, hopefully you can make it work
Okay,
without too much
thanks.
trouble. So,
Yes.
all right. Yeah, that'll be good. Once we get that integrated into Corundum, what I want to do is go through and every design that's a 25D design, you know, outfit that with this, you know, switching capability. And every board that doesn't have a 25 gig design, you know, we'll, you know, make one. So yeah, basically if a board just supports 10G, then we'll have just a single 10G design. If it supports 25G, then we'll have a 10G design and then a switchable 10G 25G design. And then if it supports 100 gig, then we'll have both of those plus a 100 gig design. So I've been trying to keep the number of designs low to simplify this sort of thing. If we need to go in and, you know, make a bunch of modifications to the transceivers and whatnot, we have less stuff to modify. But one thing's a little bit more stable. Once we get some of this functionality figured out, then we can certainly go through and add a few more design variants. Anyway, sounds like you've been making pretty good progress on that. That's good. I'm
Yes,
looking forward
thanks.
to, you know, if you want to present some slides talking about this on one of the developer meetings, you know, just let me know and we can make that
Okay,
happen. So,
I
yeah,
think I will show some slides at next week, next meeting.
time. Yeah, all right.
Yes, next
Sounds
time.
good. All right, so I think that about rounds out all of the status stuff. Looks like we lost a few people. I don't know if there's anybody else that wants to discuss anything. I think well, we still have Bob from Cisco, but everybody else from Cisco dropped off, it looks like. I don't know if Cisco has anything they want to add.
You know, I'm still absorbing it all right now, and
Okay.
you know, kind of new to this, so I'm sure we will, but not this time, right?
Oh, and
today.
also congrats,
we're
Bob,
gonna-
for being the 100th member of the Slack channel.
There it is. All right, I just joined. Yeah.
I just noticed that we were at 99 last night. I'm like, oh, hey.
All right.
Sweet.
I guess that's something.
Yeah. Well, if you
Okay.
have any, you know, general questions, you know, go ahead and fire away. I guess I can, you know, give a little just brief background on, you know, what Corundum is and how it started. Basically, the project came out of the research that we're doing at UCSD. So I don't know if you're familiar with the research group here at all, but we do work with data center networking and optical switching. So we've built a whole bunch of different optical switches over the years. And what we try to do is actually build, you know, a test network with the optical switch and, you know, a bunch of servers. And we actually try to run some data through it and ideally run some data center applications and, you know, get a sense of how everything works. You know, benchmark it, you know, is this actually a feasible thing to do? But the optical switches, you know, they operate totally differently from packet switches, right? They're making and breaking links, they're not routing individual packets. So timing becomes incredibly important. You know, we have to send things into the network when the switch is in the proper configuration. So if you're using an optical switch that runs in the millisecond time scale, you do everything in software and it works fine. But when you build a faster optical switch that's in the microsecond time scale, this becomes a huge problem. So we tried for years a whole bunch of different software solutions that just nothing worked for various reasons. It didn't scale, it used way too much CPU, it just couldn't provide the timing that we needed. So eventually I'm like, okay, screw it. We're going to do this properly. We know we can do this kind of stuff on an FPGA, but there's no existing, reference design we can build on top of. So let's build our own NIC from scratch that we can then implement this, this high precision timing on top of. And that was basically the genesis of Corundum. Once I got it relatively working and we could send and receive packets, not necessarily with the high precision timing yet, but just sending and receiving packets, I'm just like, geez, there's probably a lot of people that could make use of this, in the research community or whatever. Just having an open NIC design that you can add your own, features to and make modifications to. So we released it as open source, and well, here we are a few years later. So,
are you still working with optical switches?
Yeah, well, like I said, we're doing a bunch of link level stuff. We got a new switch element in that we're in the process of characterizing and getting kinks worked out of the system. So that's one thing that we need to take a look at is kind of the link quality going through the switch to figure out where the problems are. Are we running into issues with the transceivers? Are we running into issues with the manufacturing of the disk, the optical alignment or whatever? So yeah, it's this is why I'm going to be spending some time working on some of the link level stuff over the next couple of weeks, because this is literally part of the experiments that we're working on at the moment. Now, ideally, once we get the kinks worked out of this, we'll actually be able to run data center applications on top of this, and get an idea how this thing works from a systems perspective.
Well, there's definitely interest here because in the ultra low latency world right now, it's primarily, although maybe slowly or going to transition to 25 gig, it's 10 gig. It's 10 gig, believe it or not, right? Because that's where there's no FEC, there's no, and that's what they've used. And then the exchanges, they want to charge more for 25 gig anyway. So, of course.
Well, I guess the other question is, how much bandwidth is there really going over these connections? It sounds like you're using 10 gig links, but you're not actually moving 10 gigs worth of traffic, right?
No, it's the opposite,
Much
right?
less than that,
yeah, much less than that, except, well, there's feeds that come in normally, like you get these combined feeds that I think last time I looked was around 6 gigabits per second coming down from, like, for a feed for UDP that's multicast for feeds from market data. So they look at that, but then the actual electronic trading happens with TCP, right? So you need a TCP stack, and that's where the ultra low latency comes in. Well, it does for the receive side too, but yeah, and sometimes you have two systems running, receive, and you're looking at things or crunching numbers and then telling the other one go to make your trade, right? So but that's the features for us are very limited, and we did 10 gig only, right? But we want to look to maybe move our card, and we do have we have a 25 gig image for one of our cards, and we like our V9P, which is the largest FPGA NIC we have, which is VU9 VU9P Xilinx, which has quite a bit of logic. We only support 10 gig, right? With no 25 gig, no 100 gig, and yet we know that can support it or could possibly support it. But we, and then we could branch out into other areas. We've already got.
You don't have an FDK that supports that. It's all geared towards the low latency stuff. So.
Yeah, it's all sits towards the low latency. And we have a kernel bypass stack as well. That our own called ExaSoC for sockets-based kernel bypass. I mean, you can also do frame level, transmission. But yeah, so we have a sockets-based bypass of our own. There's others out there. There's DPDK, which is more like frame level, right? You have to manage your own things. And I've seen people in this industry actually way back. They wrote in the financial industry. They wrote like their own stack on top of DPDK, like their own TCP stack and UDP, or sockets even. We've seen all sorts of weird stuff. They don't do it anymore because there's other sorts of solutions out there, right?
Yeah, I mean, definitely not for financial, but I know there's a number of Userspace stacks that use DPDK. I think there's even some stuff where you basically like LD preload it, and then the application just uses sockets normally, but will go through this stack instead. So
yeah, that's what ours is.
Right.
The ExaSoC, yeah. And that's what open onload. I also had some time at SolarFlare too, which was, the people that had, and it's released on GitHub as well, open onload, which could conceivably be used with Corundum as well, right?
Yeah, I haven't looked at the specifics of that, but yeah, potentially. I mean, even if it requires hardware, hey, we could add some of the hardware perhaps. Yeah. No, so I think it definitely makes a lot of sense for you guys, maybe to even have, 2 different images. You have your low latency image that's for the financial stuff, and then you have kind of a more traditional NIC image that
Right.
does a lot of other stuff, isn't necessarily
Right.
optimized for low latency. So
yeah, our images do not have SIRV. They do not have VSPFs. They, very
you don't need
limited.
any of that for the low latency
No,
stuff. You
no,
want to
not if
spend
you're
all of
just
your
trying.
gates optimizing for low latency.
Yes.
So,
And
yeah.
basically our secret sauce only, well, there's some, but the 2 main things that customers that we give with our FDK that we have to purchase are the ultra low latency MAC and an ultra low latency DMA engine. That's it, right?
Ultra
Those
low
are the 2
latency on
main
top
things.
of whatever the hell PCIe gives you.
Yeah, right. So anyway, yeah, so we definitely need more of a general, the idea would have more of a general purpose type of image that other customers
Right.
can apply to a wider range of applications. Yeah.
Right. Yeah. I mean, I guess there's a couple different directions that you could take that in, right? One of them is you could build something, totally internal, or like have your own fork of Corundum or something like that. Or another possibility is, just to, utilize Corundum, we can make some changes perhaps to Corundum to, make it easier to swap that onto the cards, depending. So I don't know. I guess we can probably discuss that
tomorrow. Yeah, it'd be a good discussion.
Yeah.
I don't think we have the resources to be able, I don't know, but because I'm not back in engineering, but
right.
I'm like a field engineer. But so we don't have the resources probably to take on another project. We have enough
that's
stuff
true.
on our plate. And we also build switches too. We have FPGAs inside our switches, and we have a kit for that. And so there's a whole nother track there of ultra low latency switches, multiple layer 1, layer 2, layer 3. We have all sorts of type of switches, and we have new ones in the mix. So I don't think there's a lot of wiggle room right now for us to take on any other projects. But
can I ask you a question, Rob? Do you have a switch like on which you can build, trading system, something like that? I mean, there is a switch, but it has some customizable part on its FPGA, and one can use that part to build a trading system and just switch trades. I mean, do you have something like that?
yeah, we do. Yes, and so do some of our competitors, right? So yeah, we definitely have a switch. We have a layer 2, layer 1.5 switch where it has also crossbar, it has FPGA, and we have one that has a separate x86 module. So there's definitely options there, and we have ones with programmable FPGA. It's called the Triton, the 3550T, and it does have a VU35P. But it's so there is an FDK with it. It's very limited now on what it can do. But we also have a fusions. It's called a fusion switch. We call 3550F or FM, which does mux or very low latency, fast muxing, and also L1 at the same time, which our customers use. We're talking like things in the nanosecond range. 39 nanoseconds is like for muxing, and 5 nanoseconds across the switch for L1 with a crossbar. So that's the kind of thing. But we have FPGAs on there that you could write custom logic code. Not sure, I've been thinking about this a while, but some customers done it, but it's far easier to write it back in the host and use it as sort of like maybe something to accelerate their trade, or to look at things or just slightly modify things on on certain cases, right? So to look at packets or modify packets, or even control, like we have just a plain layer 1 switch where all it does is basically set crossbars or fan out between links, and so, and it does have some things where it can kind of look at a few packets and pick off a few things, but it basically is an L1 crossbar, that a layer 1, and then you can have something outside of it controlling and say, if this happens, switch over real fast, kind of like optical switching, only much slower, but still a way to reconfigure an electronic patch panel, right? Just boom, and I have a completely different configuration, because what happens is, like, our customers, they say, like, well, there's an event that happened in whatever in the world, I want to react, but I want to go down to my data center and replug everything else back in, or bring up all these other servers. I want to have them ready, and so I can react within a matter of seconds, versus minutes or hours or days even. It used to be.
Right, and
So,
you want to be able to do that without adding a lot of additional latency. So
absolutely,
that's where the low latency layer 1 switch comes in. Yeah, I guess the other thing is the FPGAs in those switches are not gigantic. I mean, they're big, but if you're thinking about doing something for every port, that eats up a lot of resources really fast. So
yes,
you definitely have to start worrying about scale pretty quickly when you're doing anything in the switch, versus NIC, it's just a couple of ports maybe, plus PCIe. So
right. So that, I've seen a little bit, and might be just slight modification of things, but anyone putting a bigger application on, it goes back in a host somewhere, goes back, sometimes they have GPUs which look at things, or we've seen where they have clusters of like FPGAs that are working on a problem and then communicating with each other, and maybe a controller, things like that. So yeah, absolutely. Putting it all in a switch and have the switch do the other functions it do it's a tough problem. So to do that, to get all the other things you need in the switch, because like the one we have now, the 3550T, which goes all the way to layer 3, there's a lot of things you have to do there, from VLANs to, you name it, to switch virtual interfaces, to multiple routing domains and things like that. So not to mention that you mentioned PTP. We have that on all our NICs too, which is very critical to all our traders, to use PTP, and to have PTP as a client, also PTP sometimes as a like a boundary clock, and PTP as a grandmaster. Even we have a NIC that does PTP as a grandmaster. So, and then all our switches do PTP. So that's, even though that's a whole nother area where we always need support. Now, I'm not sure the wider, well, I know that it doesn't go beyond much, the wider on it's, at least for the PTP, the basic one. There's also the industrial ones and the telecom profile. And so we see a little bit of that, but not nearly as much as just the regular PTP.
well, then I guess you also have things like White Rabbit, I think, where it's like a combination of PTP and Syncy, where you're actually, you're not just sending packets, you're also screwing around with the reference clocks.
Yeah. Yeah, and using like the signal across, the sync of the signal across across a long distance, to figure out how you're going to adjust your clock, which is a totally different paradigm than sending packets and adjusting along the way, right? And calculating all the delays among the packets, which is how normal PTP works, right? So, but we don't support White Rabbit right now. We've done a little bit of collaborative work, I think, on one of our switches. Dan Brown, who was on the call, knows more about that than what we've done. But I don't think we have a lot of uptick yet. And I haven't seen a lot of uptick actually in the industry, at least. People are interested about it. But
yeah, I think you have to be a certain level of specialization before you take that plunge, right? It's like one of those things where if you need it, you need it.
Yeah.
And then I think the other thing about White Rabbit and whatnot is you need a little bit of hardware too to make it work, like a VCO or something on the card. So
and
Potentially
So
more
we don't
people would
have it.
use it if more cards had the hardware to support it. But I don't think any of
Well,
the cards
yeah.
I have right now have the hardware to support it. So
You're right. And we don't have it either right now as a feature for any of our cards yet. I'm not even aware of any project, but yeah, Dan may know more.
all right. Well, it's great talking with you all. I guess we'll we have our meeting tomorrow, so we'll probably discuss this stuff a lot more.
All right, sounds
So,
good.
all right. Is there anything else to discuss today? Adam, John, did you want to say something?
No,
Okay.
no, I don't.
You came
I
off
don't
mute,
have
and I'm like,
something
yeah.
to say. I will
Okay.
say after 2 weeks, maybe.
All right. All right.
2 weeks.
All right. Well, we're definitely over time, but I think that's generally a good thing. That means we had some good discussions. So
Yes.
I think if nobody else has anything we want to discuss, then we'll go ahead and end the meeting for now, and we'll see everybody in 2 weeks. Hopefully we have some nice status updates for then. Not just from me, hopefully.
Okay, sounds good.
Okay.
Okay, yep,
All right.
sounds good.
Sounds
Thank
good.
you.
See you next square week.
See you guys in 2 weeks.
All right.
Yes.
Thank
Yeah. Bye.
Next day.